What if the stars were not just points of light, but signs? What if the sky was not a ceiling but a manuscript waiting to be read? In the 13th century, a scholar stood beneath that sky and listened. His name was Nasir al-Dīn al-Tusi, mathematician, astronomer, philosopher, visionary. And what he left us was not merely a book, but a legacy of wonder. Al-Tadhkirah of Ilm al-Hayya, the memoir on the science of astronomy. Travel with him as we unfold a cosmos of crystal spheres and divine symmetry, where the sun writes the architecture of the year, the moon choreographs her silvery dance, and the wandering planets reveal their secret rhythms through the elegance of the Tusi Couple. Step inside the observatory, not just a building, but a sacred engine of precision, where knowledge becomes action and science becomes prayer. Witness how geometry becomes a telescope for the mind, how philosophy becomes a map of meaning, how every celestial arc echoes divine intention, and, as we arrive at the final page, one truth remains suspended like the stars themselves. The sky is not silent. It is a voice, and you were meant to hear it. This is not just a history of science. It's a meditation on the meaning of order, the ethics of knowledge, and the eternal human hunger to understand the heavens. Subscribe, listen, and rediscover the ancient brilliance of a man who charted the cosmos, and in doing so, revealed the soul of science.
Welcome to Bookscape Epic Reads, where we dive deep into the world of popular books, exploring timeless classics and modern bestsellers alike. Join us for in-depth reviews, insightful discussions, reflections. Let roll.
There are books. And then there are books that feel as if the universe itself leaned down to whisper into the ear of a scholar. Al-Tadhkirah, F. Ilm al-Hayya, the memoir on the science of the heavens, is not merely a scientific treatise. It is a map of the heavens drawn with ink and intellect, a manuscript in which the cosmos speaks to reason. Nasir al-Din al-Tusi did not write this book in silence. He wrote it amidst the tremors of an empire's collapse, in the aftermath of the Mongol invasion, under the sky that had witnessed the burning of libraries and the silencing of minds. And yet, he dared to look up. He dared to listen again, to the stars. He was not the first to seek patterns in the motion of the spheres. For centuries, astronomers from Babylon to Alexandria had peered through the veil of night in search of divine order. They believed, as did Tusi, that to know the heavens was to know something essential about being itself. And so, his pen did not move merely with calculation, but with reverence. This introduction is not a preamble. It is an invocation, an opening of both the sky and the soul. He begins with humility. He acknowledges the greats before him, Ptolemy, Aristotle, and the scholars of Baghdad, of Andalusia, of Nishapur. But he also dares to question them, to challenge what does not align with reason or with the careful eye of the observer. For Tusi, the sacredness of tradition did not mean its infallibility. Truth, he believed, must be earned anew in every generation. The Tadhkirah is written in the language of precision, but it breathes with awe. It does not merely catalog data, it interprets, it searches, it wonders aloud. Why does the sun not move exactly as we expect? Why does the moon falter in its path? What secret architecture sustains the orbit of Mars or the strange retrograde motion of Venus? It is here, in this introduction, that Tusi reveals his dual allegiance, not just to science, but to hikmah, to wisdom. For him, astronomy was not divorced from philosophy. In fact, it was one of its purest expressions. The stars did not just illuminate the night, they illuminated the intellect. And so this chapter invites us, gently, methodically, into a universe of spheres and cycles, of orbits and angles, but also into a deeper inquiry. What is the nature of order? What is the meaning of motion? Can the finite mind of man grasp the infinite design of the cosmos? Tusi does not promise final answers. Instead, he promises clarity. He writes to clarify the ambiguities, to smooth the contradictions, and to offer a model of the heavens that does justice to both the eye and the mind. Here, In this first chapter, we step not only into the study of celestial mechanics, but into a vision of the universe as a living, breathing text, a divine geometry awaiting interpretation. To open al-Tadhkirah is to open a window onto the mind of a man who refused to let wonder die in the face of catastrophe. It is to watch the human spirit reach, through mathematics, through astronomy, through philosophy, for something eternal. And so we begin, not with a conclusion, but with a question that echoes beyond the page, beyond the stars. What is the shape of truth, when truth itself moves with the heavens? What is the language of the heavens? It is not spoken in words, nor etched in letters, nor sung in melodies. The stars, in their distant silence, do not speak as we do, yet they communicate with precision, constancy, and beauty. And there is one language, ancient, incorruptible, capable of interpreting them: geometry. In this chapter, Nasir al-Dīn al-Tusi unveils a cosmos composed not of chaos, but of form, of structured motion, governed by proportion, angle, and curve. This is not geometry as taught in dusty classrooms or scrawled on chalkboards. This is sacred geometry. Geometry as the key to cosmic order. Tusi begins by addressing the fundamental assumption of all classical astronomy. The heavens move, and they move in ways that can be measured and understood. But how? Through what conceptual lens can we transform observation into understanding? Here, he leans into the tools passed down from Euclid and perfected through centuries of Islamic mathematics: the circle, the arc, the line, and the sphere. But geometry, for Tusi, is not just a tool, it is a worldview. It is the grammar of the cosmos. Just as language shapes thought, geometry shapes our capacity to comprehend celestial motion. And in this motion, there is meaning. Why, Tusi asks, do heavenly bodies insist on moving in circles? Why does the universe favor the curvature of orbits over the straightness of lines? Because the circle, to the ancient and medieval mind, is perfect, without beginning or end, without edge or imperfection. It is the shape of eternity. And the heavens, being divine in origin, must reflect that perfection. But this perfection creates a problem. When we observe the sky, the planets do not move in perfect circles. They slow, reverse, meander, in ways that defy the elegance of pure circular motion. So how can we reconcile what the heavens ought to be with what the eye sees? Here is where Tusi's genius emerges. He does not discard geometry. He refines it. He introduces complexity without abandoning harmony. He suggests that what appears irregular is, in fact, the result of compound regularities. That what looks crooked is really composed of many perfect circles overlaid upon each other. He thus redefines perception. What we see is not necessarily what is, but it is a clue, a shadow of a deeper structure. Geometry becomes not just a way of plotting motion, but a lens of purification, a method for translating flawed perception into coherent understanding. In this way, Tusi builds a bridge between the human and the divine, because perception too is flawed. Our senses are limited, our judgments are incomplete, yet through disciplined thought, through the rigorous application of mathematical reasoning, we can reach toward what is real. We can ascend from the eye to the mind, from appearance to essence. He speaks of the orbs, concentric celestial spheres, each carrying a planet, each spinning at its own pace. But these are not merely mechanical devices. They are metaphysical, hypotheses, models that embody both physical observation and philosophical necessity. Every orb is a compromise between truth and comprehension, between what is and what we can conceive. Tusi's language is not dry, it breathes, it pulses with awe. To him, astronomy is an act of devotion. Every equation is a prayer. Every diagram is a confession of the soul's longing to comprehend its place in the vast and moving whole. And so this chapter does more than teach us the mechanics of the heavens. It teaches us how to think. It invites us to ask, what lies beyond the senses? What structure upholds the chaos we think we see? It reminds us that geometry, that cool abstract queen of the sciences, is not cold at all. It is warm with meaning. It is our first bridge between earth and sky. To study the motion of the stars is not just to study astronomy. It is to study ourselves, our need for order, our hunger for beauty, our drive to make sense of the infinite. In the hands of Tusi, astronomy becomes a kind of philosophy in motion, a theology drawn in circles and spheres, a revelation not received through angels, but through compasses and calculations. And so, we are left with a vision of a sky that is not silent, but singing, a firmament that speaks not in sound, but in shape, a universe that can be known, if only we learn how to listen to the language it speaks, the language of motion, the language of order, the language of the stars. Before humanity built machines to pierce the sky, before satellites mapped the silence above us, there were only our eyes, and the sky that never ceased to move. And move it did. With such certainty, such rhythm, such cosmic choreography, that it gave rise to both fear and faith. Each night the stars return. Each dawn the sun rises once more. Ancient peoples looked upward and saw not chaos, but order, a wheel that turned with divine steadiness. To explain this, they imagined a vast outermost sphere, al-Falak al-Aqsa, the supreme heaven, the ultimate sphere, which bore all other heavens within it like nested shells of light. In al-Tadhkirah, Fa'at ilm al-Hay'a, Nasir al-Din al-Tusi leads us into this grand celestial frame, not as a myth maker, but as a philosopher astronomer, one who seeks to understand, not merely to name. He begins with the most basic question. Why do the stars appear to move from east to west every single day? The answer, while seemingly simple, opens the door to one of the most profound concepts in medieval cosmology, the idea that all apparent motion of the heavens is caused by the rotation of a single, outermost sphere. This sphere, Tusi tells us, is not physical in the way we might imagine a planet or a star. It is not made of stone or gas. It is a framework, a theoretical construct that accounts for the daily revolution of the cosmos as seen from Earth. It is the grand axle upon which the sky itself turns. Everything within it, the sun, the moon, the planets, even the fixed stars, is mounted upon or enclosed within smaller, more intricate spheres. But the ultimate sphere, it encompasses all. It is the celestial prime mover. And yet, Tusi's treatment is not just mechanical, it is philosophical. He reflects on the nature of this outer sphere with reverence. For if it governs all visible motion, if it sets the cosmic clock into motion, then it must be nearest to perfection. It must be the most ordered, the most complete, the nearest creation to the divine. In this vision, astronomy becomes theology in geometric form. But Tusi does not accept blindly. He tests tradition. He critiques inconsistencies. He does not rely solely on the models of Aristotle or Ptolemy. He observes. He calculates. He revises. He questions whether this daily motion is truly caused by a sphere, or whether it might be a relative illusion produced by the Earth's own motion. A question that centuries later would set the stage for Copernicus. And though Tusi does not adopt a heliocentric model, his thought opens cracks in the classical geocentric armor. In this chapter, Tusi refines the coordinate systems by which astronomers measured the heavens. He defines poles and equators, not merely as lines, but as conceptual axes around which the symmetry of the cosmos reveals itself. He teaches us to see with the mind, not just with the eye, to grasp the architecture that underlies the spinning tapestry of stars, to understand. The ultimate sphere is to understand not just the motion of the heavens, but the framework of motion itself, the grammar of the universe. It is to see time emerge from space, to feel the spinning vault of heaven as both a clock and a compass, marking the rhythm of days and the direction of destiny. And there is something deeply human in all this. For in that daily motion, predictable, majestic, unstoppable, we glimpse both our smallness and our meaning. We realize that the same stars that guided Tusi still rise above us. The same sphere, whether real or imagined, still turns. And though we now speak of orbits and rotations, of gravity and relativity, the question at the heart of this chapter remains untouched. What is it that moves the heavens? And why does it move us in return? In al-Tadhkirah, the ultimate sphere is more than a solution. It is a mirror. It reflects not just the motion of stars, but the longing of a mind, perhaps all minds, to find stillness at the heart of endless movement. And so, as the stars trace their ancient arc across the night, we begin to see. This was never merely a study of astronomy. This was a study of permanence through change, of divinity in rotation, of a world that turns not aimlessly, but with purpose. Before the ticking of clocks, before digital seconds pulsed across our screens, there was one clock, vast, radiant, sovereign. It did not tick, it burned. The Mayan's sun for all of human history, the sun has not only been the source of light and warmth, it has been the keeper of time. In this chapter, Nasir al-Tusi opens a discourse not merely on astronomy, but on the architecture of temporality itself. He invites us to witness how one celestial body becomes the great architect of rhythm, the sculptor of the calendar, the divine metronome of life on earth. But to know the sun, we must begin with its motion, or more precisely, its apparent motion. To the eye of the terrestrial observer, the sun rises in the east, ascends the vault of heaven, and descends into the west. This daily circuit, like the stars, is caused by the ultimate sphere. But unlike the fixed stars, the sun slowly slides along a more complex path, the ecliptic, a tilted circle that intersects the celestial equator. Tusi studies this motion not only to track the days, but to decode the seasons, to understand how the sun's shifting position leads to summer's blaze and winter's retreat, to spring's rebirth and autumn's decay. Each solstice, each equinox, is a cosmic hinge, a moment where the great wheel of time pivots. Tusi maps these hinges with mathematical care, calculating declinations, angles, and latitudes. But behind these numbers is a vision. That time is not a line, but a cycle that folds back on itself year after year, like the revolutions of the heavens. And so emerges the calendar, not as a cultural invention, but as a mathematical translation of cosmic order. Tusi draws upon the legacy of Persian, Indian, and Islamic calendrical science, refining the solar year with a precision that would later influence generations of astronomers. He distinguishes between the tropical year, the time between two vernal equinoxes, and the sidereal year, tied to the sun's return to the same position among the stars. These subtle differences are not mere curiosities. They are the fractures where time and motion drift apart. Tusi seeks to reconcile them, to keep the calendar in harmony with the sky. But this is not merely an academic exercise. The calendar governs ritual and agriculture, fasting and feasting, navigation and narrative. It tells farmers when to sow. It tells mystics when to pray. It orients human life within cosmic law. For Tusi, the sun is not a distant ball of fire. It is the illuminator of temporal form. It divides the shapeless continuum of time into measurable patterns. It offers a rhythm to life's chaos, a melody to which all earthly processes dance. It is the geometer of destiny. And yet, Tusi is no naive sun worshipper. He knows the sun is neither God nor oracle. It is a created thing and a servant of divine order, not its source. But within its movement, its constancy, its elegance, we glimpse the echo of the one who set it in motion. This chapter also carries the subtle weight of critique. Tusi does not accept every traditional astronomical model blindly. He tests, he recalibrates, he adapts. His approach is at once deeply reverent and rigorously empirical. Faith does not preclude correction. Revelation does not erase observation. And so, the calendar becomes not just a record of days, but a testament to humanity's striving to live in alignment with the heavens. To mark time is to participate in a divine order. To measure the year is to enter into sacred architecture. Even today, we live by this architecture, though we seldom notice. We speak of equinoxes. We set clocks to solstices. We divide our lives into years and months and days, forgetting that these divisions are shadows of the sun's path across the sky. Tusi does not forget. He reminds us that beneath every hour is a circle, beneath every season a cycle, beneath every calendar a star. In the sun's path he sees the elegance of a divine clock. In time's passage he hears the echo of eternity. The year is not just a span. It is a structure, celestial, precise, holy, and the sun, brilliant, unfailing, is its architect. If the sun is the architect of the year, vast, burning, and constant, then the moon is the painter of the night, subtle, shifting, intimate. Where the sun governs with grandeur, the moon whispers with gentleness, casting its rhythm in shadows and silver. In this chapter, Nasir al-Tūsī turns his gaze from the blazing heart of the solar system to the soft companion of the earth, the moon, nearest of the heavenly bodies, most tender in its movement, and most intimately tied to human perception of time, emotion, and change. The moon, he writes, is the closest of the celestial orbs, and yet it is among the most mysterious, because it does not shine by its own light, but by reflection. It is not a fire, but a mirror. It receives and gives. It is passive, and yet profoundly active, shaping tides, stirring sleep, marking sacred calendars, and illuminating the inner night of the soul. Tusi begins with proximity. The moon's nearness is not merely spatial, it is experiential. It moves swiftly across the sky. It rises and sets at different hours each day. It waxes and wanes before our eyes, changing its face without ever ceasing to be itself. No other celestial body feels so alive. And in its changes, it teaches us about light. The phases of the moon, crescent, quarter, gibbous, full, are not illusions, nor accidents, but the result of its position relative to the sun and earth. Tusi guides us with careful geometric diagrams. Here, the angle of reflection. There, the cause of a shadow. He is not merely explaining astronomy. He is unfolding a metaphor of knowledge itself. For the moon reveals a profound truth. Light is always present, but we perceive it only in fragments. Just as the moon is always whole, though it appears to grow and shrink, so too is truth ever complete. But our vision of it is partial, changing with our position and perspective. In this way, the moon becomes more than a subject of astronomy. It becomes a philosophical emblem, a symbol of how knowledge is received, not generated, of how the mind reflects the light of the cosmos without ever producing it on its own. Tusi then leads us to the wonder of eclipses. Those moments when the moon steps into alignment with the earth and sun, and darkness falls like a veil. A lunar eclipse, he explains, is the earth's shadow cast upon the moon. A solar eclipse, the moon obscuring the sun's light. These are not portents of doom, as many believed, but majestic alignments, geometries of absence, moments when light reveals itself by its own occlusion. But to explain these, Tusi does not rely on myth or superstition. He leans into mathematics, into spherical trigonometry and observational tables, drawing precise models of orbits, inclinations, and intersections. He shows that the moon's path is inclined to the ecliptic, and that eclipses occur only when certain conditions align, not by chance, but by celestial law. This is not the cold detachment of a mere scientist. This is the reverence of a philosopher who believes that reason is a form of worship. That to trace the moon's path is to trace the signature of divine intelligence written in the sky. Yet beyond the science, there is always the human. Tusi never forgets that the moon is not merely a body to measure, but a presence to feel. Its phases govern the lunar calendar, which shapes Islamic rituals, the fast of Ramadan, the pilgrimage of Hajj, the sacred months of reflection and return. It guides the agricultural cycles, the tides of the ocean, and even the pulses of the human body. Thus, to understand the moon is to understand our intimacy with the cosmos. We are not separate from the heavens. We are wrapped in their cycles, mirrored in their rhythms, carried by their light. And so, this chapter is not merely an astronomical lesson. It is a meditation on change, dependence, and the art of receiving light. It asks us to consider, what does it mean to shine without burning? What does it mean to reflect without distortion? What does it mean to be near and yet part of the eternal sky. Tusi answers not in poetry, but in perfect lines, in measured arcs, in circles drawn with the humility of a servant and the clarity of a sage. His diagrams are not only mathematical, they are spiritual maps, guiding the mind from motion to meaning, from curve to contemplation. In the end, the moon teaches us this: that proximity does not mean simplicity, that reflection is not weakness, but grace, that darkness and light are not enemies, they are dancers. In the silver face of the moon, Tusi sees a reflection of the human soul, always changing, always orbiting, never luminous on its own, yet capable of reflecting the light of the real, if only it turns at the right angle. The moon is not a cold rock. It is the philosopher's mirror. It is the calendar of hearts. It is the night's gentle teacher. There is order in the heavens, that much is certain. The stars arc through the night with a serenity that seems timeless, faithful. But then, there are the planets. These are not stars. They are wanderers, in Greek, planets. Those that stray. Their movements defy the fixed perfection of the celestial sphere. They loop backward, they pause in their tracks, they retrograde. Like dancers gone astray from the heavenly choreography, and yet they return. There is a pattern behind the anomaly, a deeper harmony behind the apparent chaos. And it is here that Nasir al-Dīn al-Tusi places his focus. In this chapter, The Planets, Patterns, Anomalies, and the Tusi Couple, Tusi opens the vault of one of the most complex questions of pre-modern astronomy. How can the heavens be perfect, and yet the planets behave imperfectly? He inherits this problem from Ptolemy, whose geocentric models, while useful, are cumbersome, inelegant, and mathematically strained. Ptolemy invoked epicycles upon deference, stacking circles upon circles to explain the backward loops of Mars, the pauses of Jupiter, the oscillations of Mercury. His model worked, but it violated the principle of heavenly simplicity. Tusi, both astronomer and philosopher, refuses to rest there. He searches for a solution that is not merely computational, but ontologically elegant, cosmologically sound, philosophically pure. Enter the brilliance of innovation. A simple yet revolutionary device. A small circle rotating inside a larger circle with twice its diameter, in such a way that the smaller's motion negates part of the larger's, producing linear motion from two circular ones. What Ptolemy had explained with clumsy epicycles, Tusi now explains with graceful geometry. With this coupling, he could preserve the axiom of uniform circular motion, the sacred demand of Aristotelian cosmology, while still accounting for the strange accelerations and retrogradations observed in the planets. It is, in a word, genius. But more than that, it is philosophy translated into motion. Where others saw irregularity, Tusi saw layers of harmony. Where others patched models, he harmonized contradictions. He did not surrender to complexity. He refined it until it aligned with both reason and the cosmos. He applies this not just to one planet, but to the entire visible set. Mercury, swift and elusive, so close to the sun it hides in its glare. Venus, bright and veiled, moving in epicycles of beauty. Mars, whose retrograde puzzled watchers for centuries. Jupiter, ruler of the skies, moving slow and grand. Saturn, the old boundary of the known cosmos, circling in the long dark. Each of these planets has a story, a path, a music. Tusi charts their anomalies with tables drawn from meticulous observation at his famed Memoir Observatory, one of the greatest scientific institutions of its time. He records their positions, their speeds, their apparent motions. And then, he fits them into a unified cosmological structure, yet he does not violate the ancient harmony of the spheres. Instead, he refines it. This chapter is not only a technical tour de force, it is a philosophical triumph. It exemplifies Tusi's vision of the universe, not as a battlefield between data and doctrine, but as a symphony of reason and observation, where even the errant wanderers fall into place, not by force, but by deeper understanding, and here lies a deeper lesson. The planets, once symbols of unpredictability, become through Tusi's insight symbols of reconciliation. They remind us that not all disorder is disorder, that sometimes what seems like deviation is the echo of a deeper logic, that with patience, precision, and faith in the rationality of creation, the universe yields its secrets. Indeed, Tusi's model would echo through the centuries. It would influence Copernicus, who may have drawn directly from Tusi's work in formulating his own heliocentric model. The Tusi couple, though born within the geocentric framework, cracked open the door to new paradigms. It was a bridge from Ptolemy to modernity, a proof that one could question, refine, and yet still believe in the intelligibility of the cosmos. And so this chapter is not just about astronomy. It is about the mind's power to seek harmony and complexity, to transform confusion into clarity, to redeem the strange with thought. The planets, in all their wandering, are still part of the divine dance. Beneath their loops is a circle. Beneath their chaos is law. Beneath their movement is meaning. Tusi teaches us to trust the sky, not because it is always simple, but because it is always knowable. There comes a point in the study of the heavens when numbers are not enough. You may chart the courses of the stars, count the loops of the planets, even construct models to represent the great turning spheres. But at some moment, the mind grows quiet and asks, why? Why are there stars? Why do they move with such majestic repetition? Why should the universe be intelligible at all? Why does it stir not only the eye, but the soul? In this chapter, philosophical cosmology, order, purpose, and divine wisdom, Nasir al-Dīn al-Tusi moves beyond tables and geometries. He turns to what lies beneath the structure of the cosmos, the principles that breathe meaning into the mechanisms, the metaphysical soul behind the astronomical body. This is not astronomy alone. It is hikmah, wisdom, in its deepest Islamic sense, the synthesis of observation and reflection, calculation and contemplation, science and sacredness. Tusi begins by asking a daring question. What kind of universe is this, that it can be known? He observes a world composed not of chaos but of coherence. The planets follow paths. The stars remain fixed. The elements move by nature. Light obeys its angles. Shadows trace time. Everything in the heavens, he writes, exhibits order, nizam, an order that is not accidental but purposeful. It is an order that implies intent. From here, he guides us into the heart of classical Islamic cosmology, that the cosmos is not merely a physical structure, but a divinely willed reality. Its design reflects not only how things are, but why they are. The celestial spheres for Tusi are not mindless mechanisms. They are intelligences, or more precisely, moved by intelligences. Drawing from the legacy of Aristotle and Avicenna, he speaks of the movers of the spheres, metaphysical beings whose desire for the divine absolute sets the heavens in motion. Their movement is not mechanical, it is longing. The stars move not because they must, but because they yearn toward the necessary being, toward pure actuality, toward the one in whom all perfections are united. Here, astronomy becomes theology. The rotations of the firmaments are acts of worship. The orbits of the planets are prayers in motion. Every celestial revolution is a testimony of order and beauty, declaring that the universe is not blind, but meaningful. Tusi's cosmos is not anthropocentric in the modern sense. Man is not the center, but he is the knower. It is by the rational faculty, the AQL, that man mirrors the order of the heavens within himself. Just as the celestial spheres are drawn toward the divine by their movers, the human intellect is drawn toward knowledge, unity, truth. Thus, to study the sky is to follow a trace of the divine mind. Every law discovered, every orbit mapped, every anomaly understood durafuri is a glimpse into God's wisdom, hikmah ilahiyah. But this is not a static vision. Tusi emphasizes that the cosmos is not merely ordered, it is graded. It flows from the one through successive levels of being, from the necessary to the intellects, from the intellects to the spheres, from the spheres to the elements, and finally to the world of generation and corruption. Alam al-kaun wal-fasad, This ontological hierarchy is not just vertical, it is teleological, full of purpose. Each level exists to reflect and mediate the level above it. Light flows downward, being cascades. Each lower world bears the imprint of what precedes it. In this way, Tusi gives a vision of the cosmos that is sacramental. The world is a veil, but also a revelation. Matter conceals, but also transmits. The sky is not merely high, it is holy. And within this grand design, the human being emerges not as a spectator but as a participant. For within the microcosm of the soul is the echo of the macrocosm. The intellect can ascend just as the spheres revolve. Through knowledge, man climbs. Through reflection, he orbits the divine. Thus, the study of astronomy becomes not only science, but salvation. This is why Tusi wrote not only astronomical treatises, but also philosophical works, ethical treatises, and metaphysical meditations. He understood what the modern world too often forgets, that science without metaphysics is hollow, and truth without meaning is blind. In the movement of the stars, he saw the grammar of divine speech. In the balance of the heavens, he felt the wisdom of the Creator. In the harmony of numbers, he sensed the unity of being. The universe, to Tusi, is not only knowable, it is intended, not only lawful, but luminous, not only vast, but filled with purpose. To study the cosmos is to love it. To love the cosmos is to seek its source, and to seek its source is to return to God. This is not just cosmology. This is philosophical astronomy, where the curve of a star's path is a proof of wisdom, and every orbit is an argument for meaning. It is the sacred science of knowing where you are and why it matters. Tusi ends not with a diagram, but with a doorway. The heavens are not a ceiling, they are a ladder. At a certain point, thought must leave the page. It must leave the geometry of the diagram, the elegance of the equation, the dream of the ideal sphere, and walk into the world, into the dust, the cold, the wind, the night, into the real. And in this chapter, the Observatory, knowledge in action, Nasir al-Tūsī does just that. He steps out from behind the abstractions of cosmology and shows us where knowledge lives, breathes, and labors. The Observatory, not merely a building, not merely a tower, but a temple of intellect, built not of stone alone, but of purpose. The Moraga Observatory, constructed in the 13th century in the northwestern highlands of Persia, was one of the most sophisticated centers of scientific activity in the medieval world. And it was Tusi's masterpiece, not in theory but in practice. He did not dream in solitude, he built. He gathered a team of astronomers, mathematicians, geometers, engineers, and artisans, Persians, Arabs, Kurds, Greeks, Mongols, a fellowship of minds devoted not to conquest, but to comprehension. Together, they erected instruments of astonishing precision, quadrants of bronze that measured the altitudes of stars, armillary spheres that modeled the heavens in nested rings, astrolabes and mural sextants calibrated to the finest angles, and tables, ZGs, where each data point was a prayer of precision. This was science not as ideology, not as industry, but as a spiritual vocation. Every instrument, every carved scale, every calculation scratched in ink on parchment was a gesture of reverence toward the sky. Tusi did not study the heavens to dominate them. He studied them to align with them. He knew knowledge is not a matter of speculation, it is action. It must be tested under the stars. It must be questioned by the real. Thus, the observatory was not just a site of observation, it was a crucible of verification. Here, planetary models were compared against centuries of recorded motion. Here, Ptolemaic theories were refined, corrected, or discarded. Here, the Tusi couple was not only imagined, it was proven by data drawn from the night sky. But beyond the instruments and measurements, there was something else, something more human. In the long hours of cold nights and candlelight, these scholars cultivated a community of inquiry. They read Avicenna, debated Aristotle, interpreted Ptolemy, and translated the works of the Greeks and Indians into Arabic and Persian, all the while creating something new. And here lies the essence of the observatory. It is the space where tradition becomes transformation, where inherited models are honored, but not idolized, where theory bows to evidence, where questions are not silenced, but sharpened. Tusi's vision of science was not closed. It was open, humble, ever-evolving. He understood that the world is not static, and so the pursuit of truth must not be static either. Even in a cosmos governed by divine order, the details are to be discovered, not dictated. This is what made Moraga so revolutionary. It was not a relic of ancient science, but a forge of future knowledge. Indeed, many historians now believe that European astronomers, including Copernicus, had access to the works produced in Moraga, especially Tusi's planetary models. Thus, the observatory was not only a Persian achievement, it was a civilizational bridge, carrying the torch of knowledge from east to west, from Islam to Christendom, from antiquity to modernity. But there is a deeper lesson still. In a world increasingly obsessed with technology, with automation, with progress for its own sake, Tusi reminds us that science must be rooted in ethics, in humility, in awe. The observatory, in his hands, becomes a moral space, a sanctuary where the mind and the cosmos reflect one another. He shows us that action without understanding is dangerous, but understanding without action is empty. Only when the two meet, when theory enters the world and the world enters theory, does knowledge truly live. So let us remember the observatory not as a museum of instruments, but as a living metaphor. Place where thought meets sky, where reason bends to reality, where the stars are not only seen, but known, revered, and shared. The sky is not merely a spectacle, it is a summons, and the observatory is our reply. What remains when the instruments are packed away, when the domes fall silent, and the night turns once more to dawn? What endures when the hand of the astronomer is stilled? The sky remains, and so too does the trace of the mind that once studied it. In this final chapter, A Legacy Written in the Sky, Nasir al-Tūsī closes the curtain on a lifelong dialogue with the heavens. But the tone is not one of finality, it is one of continuity. For the true legacy of knowledge is not in the conclusions drawn, but in the questions left open, suspended, like stars above the horizon. Tusi knew this, and so he did not write to end a conversation, but to pass its flame forward, into the hands of generations yet unborn, across lands he would never see, in languages he would never speak. What he left behind was not merely a treatise, but a testament to the idea that truth is not a possession but a pursuit, that the universe is not a sealed mechanism but a living invitation, and that the soul of science, at its highest point, becomes indistinguishable from the soul of devotion. From the earliest pages of al-Tadhkirah, we watched as he mapped the firmament with the compass of reason. We walked through the celestial spheres, traced the movements of the planets, and beheld the elegance of the Tusi Couple, that elegant model which allowed circles to mimic the strange looping paths of the real heavens. We stood beneath the solar arc, understood the role of the moon in shaping calendars and tides, followed the errant paths of Mars and Saturn, and measured the arcane harmony that bound it all together. And then, we stepped into the observatory, not just as a place of data, but as a spiritual workshop, where knowledge was forged through action, humility, and precision. In that sacred space of domes and instruments, Tusi taught us a lesson more enduring than any star chart, that to truly know the world is not to master it, but to align oneself with its order. That wisdom arises not from domination, but from coherence, from harmony between the knower and the known. That the universe is not mute, it speaks, and its language is mathematics, movement, and meaning. But perhaps the greatest legacy Tusi leaves us is not in his calculations, but in his cosmological ethics. In his vision, knowledge is not neutral, it is sacred. To study the stars is to engage in a form of worship, a contemplative reverence for the divine mind whose signs are scattered across the sky. Science, when rightly practiced, becomes a path of the soul, a form of ascent, not just vertically through the spheres but inward, toward the rational core of the self, and upward, toward the source of all being. This is why his legacy endures, not only in Persia, not only in Islam, but across the history of astronomy itself. Indeed, it is no coincidence that centuries later, in the heart of Renaissance Europe, figures like Copernicus would engage ideas first crystallized in Moraga, ideas born of Tusi's pen. The Tusi couple would help reshape the Western sky, just as it once revolutionized the Islamic world's understanding of planetary motion. Yet few today remember his name. And yet, he is there. He is there in every ephemeris that records the heavens with precision. He is there in every observatory dome still standing against the dark. He is there in the very idea that science can be exact and ethical, rigorous and reverent, mathematical and meaningful. He is there quietly, like the stars he once charted. And so as we close al-Tadhkirah fa-ilm al-Hay'a, we do not end with finality. We end with echo, with the sense that behind the vast silence of space, there is still an ancient whisper. A voice from a high plateau in Moraga, calling out, "O seeker of knowledge, look up, and in that looking, know yourself." The sky is not indifferent, it is intentional, and those who study it with sincerity leave their mark not only in books but in the very arc of the stars.